Hi guys, welcome back to my channel here. Okay, so in this video I'm going to show you how to simplify radicals. So we're going to be looking at square roots, cube roots, fourth roots, and those radicals with variables. So the first thing we're going to look at here is simplifying square roots. Now in order for you to simplify square roots, you need to know what a perfect square is. So we're going to go over some of the perfect square here because you're going to need to know these numbers in order to simplify square roots. Okay, so let's take a look at the first perfect square. So what is square root of 1? Well, square root of 1 is 1 because 1 times 1 is 1. And then the next perfect square is 4. Okay, so that's going to give us 2. And then the next perfect square is 9. And that's going to give us 3 because 3 times 3 is 9. And then square root of 16, that would be 4. And then square root of 25, then that's going to be 5. And then square root of 36, well, that's going to be 6 because 6 times 6, 2 times is 36. Okay, so and then the next one is square root of 49, and that's going to be 7. Okay, and then it goes to 64, and then square root of 81, and then square root of 100, and that's going to be 10. Okay, so again, in order for you to simplify square roots, you need to know these numbers that are the perfect square. Okay, so let's take a look at the first example here. So here we're going to simplify 4 times square root of 320. Now we have to simplify this because we do not know what square root of 320 is. It's not a perfect square. So there's different ways of doing it, but we're going to do it this way. So here's a method of how to do it. So to simplify is to rewrite the radicand. So the radicand is the number underneath the radical sign. So according to this, your radicand is 320. So this is the radicand. So we're going to rewrite 320 as a product. Product is multiply of perfect square using the perfect square and then some other numbers. So perfect square multiply with some other number, okay, to get the 320. So here your perfect squares are 1, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, and then so on. Okay, so we're going to use these numbers to rewrite 320. Okay, so which one of these numbers can go into 320? And you always want to use the largest number that can go into 320 because this way you don't have to continue to simplify. And I'm going to show you what I meant by that. Okay, so here we have 4, bring down the 4, and then square root of 320. So which one of these numbers can go into 320? Okay, looks like we can use 64 because 64 goes into 320 5 times. Okay, so we're going to rewrite 320 using 64 times 5. So continue to simplify this, bring down the 4, and then we know what square root of 64 is. Well, square root of 64 is going to be 8 because 8 times 8 is 64. Okay, and then we do not know what square root of 5 is, so we're just going to leave it alone. Okay, so then we go 4 times 8 is 32. and then square root of 5 stays the same. Okay, so the final answer is 32 times square root of 5. I mean, there's other way to rewrite 320, okay, without using the 64. Okay, if you were to do that, let's say, for example, you went on and instead of using 64 times 5 to rewrite, and then you went on to do this. Let's say you leave the 4 alone and then square root of 320. You can use 16 times 20. Okay, so then 4. Now square root of 16, we know what that is. Well, that's just going to be 4. And then square root of 20, we don't know what that is. So we'll leave it alone for now. Okay, so now here we have 16. 4 times 4 is 16. And then times square root of 20. Now, square root of 20 can be continued to simplify. Okay, you have to continue to work with the 20. So we can rewrite 20 using 4 and 5. So square root of 4 times square root of 5. So we know that square root of 4 is 2. Then 16 times 2, square root of 5. Then your final answer here is going to be 32 square root of 5. As you can see, you end up with the same thing, but this process takes a little bit longer because you have to continue to simplify. That's what happened if you did not use the largest perfect square to break up the radicand. So here I'm going to show you how to simplify cube roots. Now, in order to simplify cube roots, you need to know what a perfect cube root is. And we're going to go over a few of the perfect cube roots. So this way you know how to find it. If I take cube root of 1, well, that's going to be 1. Okay, so this is cube root because the index number here is a 3. Cube root of 1 is 1 because 1 times 1 times 1, 3 times, is 1. And the next perfect cube is going to be cube root of 8. Well, that's going to be 2. Cube root of 8 is 2. 2 times 2 times 2 is 8. And then cube root of 27. Well, cube root of 27 is going to be 3. And then the next one would be cube root of 64. And that's going to be 4. And then cube root of 125 is going to be 5. Because 5 times 5 times 5, 3 times, is 125. Okay, so these are the first 5 perfect cube roots. And you're going to need to know these numbers in order for you to simplify those cube roots that we do not know. So here we're going to simplify 3 times cube root of 108. So here we do not know what cube root of 108 is. It's not a perfect cube. Okay, so we're going to simplify this, and one of the way that we can do it is to rewrite the radicand. So the radicand here is the 108, the number inside the radical sign. That's a product. Product is multiply. Okay, using the perfect cube and some other number. Okay, so we're going to rewrite 108 using these numbers. So we know cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, and then so on. All right, so the 3 is outside. We don't do anything to that yet. And then here we have cube root of, now 108, how do we want to rewrite that? Well, 8 cannot go into 108 exactly. Okay, so how about 27? Can 27 goes into 108? Yeah, 27 can go into 108 3 times. So we can rewrite as 27 times 3. Okay, so we rewrite the 108 as 27 times 3. And then continue to simplify here. We have 3, bring down the 3. And now we know what cube root of 27 is. So cube root of 27, well, that's going to be 3. Okay, we know that number. And then cube root of 3, we don't know. So we're just going to leave it alone. Cube root of 3. Your final answer here is going to be 3 times 3. Well, that's going to be 9. And then cube root of 3. Okay, so now we're going to look at fourth roots. Again, in order to simplify fourth roots, you need to know what a perfect fourth root is. So let's go over some of those numbers. So what is fourth root of 1? Well, fourth root of 1 is going to be 1. Okay, because 1 times 1 times 1 times 1, 4 times, is 1. Okay, what's the next perfect fourth root? Well, the next perfect fourth root is going to be 16. That's going to be 2, because 2 times 2 times 2 times 2 is 16. Then the next number is going to be fourth root of 81. Fourth root of 81 is going to be 3, because 3 times 3 times 3 times 3, 4 times, is 81. And then we'll do one more. Fourth root of 256. Well, that's going to be 4. Because 4 times 4 times 4 times 4, 4 times is 256. You need to know these numbers, 16, 81, 256. Okay, so let's take a look at an example here. Okay, so here we have 3 times fourth root. The 4 is the index number, 162. Okay, we're going to make it simple. Okay, so fourth root of 162, we do not know what that is. That's not a perfect fourth root. So we're going to have to rewrite this number. Okay, so here's the method of doing it. So again, we are going to rewrite the radicand as a product of a perfect fourth and some other number. Okay, so let's write down some numbers that are perfect fourth root. So we know fourth root of 1 is 1. Fourth root of 16 is 2. Fourth root of 81 is 3, and then so on. Okay, so tell me here, how can we rewrite the 162? Okay, using these numbers, 16 and 81. Looks like 81 can go into 162 exactly. Okay, so fourth root. Okay, so 81 can go into 162 2 times. So 81 times 2 is going to give you 162. Continue with this. We bring down the 3. And we know what this number is. Fourth root of 81. Well, that's going to be 3. And then fourth root of 2. Well, we don't know what fourth root of 2 is. So we just leave it alone. Okay, so now we can multiply the 3 with the 3. And that's going to give us 9. And then fourth root of 2, we don't know. So we're just going to leave it alone. Okay, so this is your final answer. Okay, so when you simplify 3, fourth root of 162, okay, you get 9, fourth root of 2. Okay, so now we're going to get into simplifying radicals that have variables. Okay, so let's take a look at this example here. So here we have square root of 32 x to the 4th y to the 9. We're going to simplify this, but before we do that, okay, there is an important principle that we need to know when working with an even number roots. It is called the principal square roots non-negative. Okay, you have to understand that when you find an even root of an even power and the result is an odd power, you must use absolute value to ensure that the answer is not negative. Okay, so for example, let's say you take square root of x to the 4, okay, and then y to the 10, just for an example. This is an even root because the index number is a 2, so okay, your index number for square root is a 2, so it's an even root. Okay, and then as you can see, you're taking an even power. So you see how here you have an even power. So 4 is even, and then 10 is even. Okay, so if you take square root of x to the 4th, y to the 10th, you're going to get x squared, and then y to the 5th. So which one of these came out to odd? Well, this one right here, 5, is an odd number. So because it comes out to an odd number, you need an absolute value around y to the 5th. Okay, because this right here, y to the 5th, can be a negative number. Let's say y is a negative number, and then when you raise it to the 5th power, it's going to stay negative. Okay, so to ensure that your answer is not negative, you need to take an absolute value of it, because absolute value of a negative number comes out to positive. Now this one is okay. See, the x squared is fine. You don't need an absolute value around x squared because x squared is a positive number. Even though if x is a negative number, when you square it, you're going to end up with a positive number. Okay, so therefore you don't need an absolute value around it. It's only those that comes out to an odd power. Now, if you're dealing with an odd root, let's say your index number is 3, 5, 7, then this does not apply. So we're going to simplify square root of 32 x to the 4th y to the 9. So we're going to rewrite 32, okay, using a perfect square that can go into 32. So that would be 16 times 2. Okay, 16 is a perfect square. We know what that is. Okay, and then over here, x to the 4. Now your index number is 2. Okay, because it's square root. So here, it looks like 2 is a multiple of 4. 2 can go into 4. Okay, so therefore, this is a perfect square. Okay, so we're just going to leave it alone. We don't need to rewrite that. And then with the 9, 2 cannot go into 9. Okay, so we're going to have to rewrite this. But we know that 2 can go into 8. So we would like to rewrite that using y to the 8 times y. Okay, so that's going to give us y to the 9. This is a perfect square. We know what this is. So that's going to be 4. Okay, this stays inside. And then we know what this is. Square root of x to the 4. So 2 goes into 4 2 times. So that's going to be x squared. And then we don't need an absolute value around x squared because it's a positive number because of the square. 2 goes into 8 4 times. So y to the 4. Again, we don't need an absolute value around y to the 4th because it's a positive number. And then square root of 2y. Okay, so you can see the 2, square root of 2 we don't know, and then square root of y we don't know, so it stays inside the radical sign, so that is your new radicand. Okay, so the final answer here is y x squared y to the 4th times square root of 2y. Okay, so let's look at the next example. So here we have cube root, so your index number is a 3, and then it's 56 r to the 8, and then s to the 4. So now we're working with cube root because your index number is a 3. So this does not apply. Okay, so you don't need an absolute value at all. Okay, no matter what. So we're going to rewrite now. We have to rewrite 56 using a perfect cube. So we know perfect cubes are what? 1, 8, 27. Okay, and then so on. Looks like 8 can go into 56 7 times. So we're going to rewrite 56 using 8 times 7. Okay, and then for the r, 3 cannot go into 8, but 3 can go into 6. So you want to rewrite that using 6 and 2. So r to the 6 times r squared, that's going to give you 8. Okay, and then here 3 cannot go into 4, but 3 can go into 3. So you want to use s to the 3rd power times s. So cube root of 8, okay, we know that's going to be 2. Okay, so the 7 stays inside the radical sign. And then cube root of r to the 6, we know that's going to be r squared because 3 goes into 6 2 times. Okay, and then this stays underneath the radical sign, and then this here, 3 goes into 3 1, so that's just going to be s. And then we have cube root of the radicand, so your radicand is going to be 7r squared s. So 7r squared s. Okay, so this is your final answer. Okay, let's take a look at the next example. So here we're going to work with, okay, so here we have 4th root of 48 to the 8 and then n to the 3rd power. Okay, so here we have 4th root. So now we have to rewrite 48, okay, using this perfect 4th root. So we know what 4th root of 1 is 1. 4th root of 16 is 2. 4th root of 81 is 3, and then so on. Okay, looks like 16 can go into 48 3 times. We want to rewrite using 16 and 3. Here, your index numbers are 4. So here, 4 can go into 8. So this one is good. So we're just going to leave it as is. Okay, and then here, 4 cannot go into 3. But 3 is a smaller number. Okay, see how the power here is smaller than the index number. So that's not going to come out at all. Okay, it's too small. Okay, so that's going to stay inside. Okay, so we're going to be able to take 4th root of 16, and then we're going to be able to take 4th root of to the 8. Okay, and then the 3 and the n to the 3rd power, that's going to stay underneath the radical sign. Okay, so 4th root of 16 is 2 because 2 times 2, 4 times is 16. And then 4th root of to the 8 is squared. So here we don't need an absolute value around squared because see how that's even. So this is going to be a positive number. no matter what. And then your radicand is going to be 3n to the third power. Okay, so this is your final answer. Okay, so let's take a look at one more. Okay, so this will be your last example. So here I have 5 times 4th root of 112. Okay, c to the 24, and then d to the 18. Okay, so we're going to simplify this. So here 5 is outside. Okay, so we bring down the 5. Okay, now 4th root. So we need to rewrite 112 because 4th root of 112 is not a perfect 4th root. Okay, so let's take a look at these numbers again. Perfect 4th roots. You got 1. You have 16. 4th root of 16 is 2. And then you have 81, and then so on. Okay, looks like we can divide by 16. So 16 goes into 112. It's going to be 7. So we can go 16 times 7. That's going to give us 112. And then here, c to the 24. Well, your index number is a 4, and then 4 can go into 24 exactly 6 times. So that's okay. So that's a perfect 4th root. So we don't need to rewrite that. And then d to the 18. 4 cannot go into 18, but 4 can go into 16. Okay, so we're going to do d to the 16, and then d2 to make it 18. Okay, sorry about the mess here, but I hope you guys can see it. All right, so bring down the 5, and then 4th root of 16 is going to be 2. So 5 times 2. And then this one stays inside the radical sign. Now 4th root of c to the 24 is going to be c to the 6. Because 4 goes into 24 6 times. And then d to the 16 is going to come out as d to the 4th, because 4 goes into 16 4 times. And then you have 4th root of, so your radicand is going to be 7d squared. Okay, so your final answer here is going to be 10. 5 times 2 is 10. C to the 6, D to the 4th, and then 4th root of 7D squared. Okay, and then we don't need an absolute, even though we're working with an even root and even power, but since these came out to even, you see how 6 and 4 are even numbers, we do not need absolute value for those. Okay, so this is your final answer. Okay, so that is how you simplify radicals that have variables. Okay, so I hope these examples are easy enough for you guys to understand. Hope you like the video. Okay, if you do, please help share and subscribe down below. And I thank you so much for watching it. I'll see you guys next time. Thank you.